So this is how to make free phone calls, basically, using the new technology that's being rolled out very rapidly without actually being evaluated by all of the telcos. Next slide. Okay, the agenda for the talk, which I came up with very rapidly at about 3 o'clock this morning, so I might not remember it too well, is an introduction where I will go over basically a little bit of background on voice over IP, which is probably unnecessary given the technical crowd we have here. We'll then do an overview of voice over IP technology, particularly focusing on the protocols and how they're implemented and why they're not as secure as they should be. We'll look at the infrastructure, and then we'll look at security, which is the fun stuff, where we go over several of the attacks that I've been developing over the last year. And if we can get internet access, then we actually have live demos. Ooh. We're going to hack Singapore for the Malaysians in the audience. Okay, voice over IP. There are good things, like... Oh, all right, I have to move. Okay. There's good things about voice over IP. It's cheap. We all get cheap phone calls. That's very good. It's been exploding very rapidly. I remember in 2002 when I first started working on VoIP with Ophir, I used to make fun of him, telling him that it would never catch on, and I guess I was wrong. But it's grown very, very rapidly over the last year, and it's going to probably continue to grow very, very rapidly, particularly because mobile phone operators charge so much fucking money, and internet telephony was going to do them pretty badly. One of the big problems is that all of these telcos, in a desperate bid to make money out of voice over IP, are marrying the PSTN, which is the Public Service Telephone Network, to the internet. And if you think about that for a minute, you'll realize what a bad idea it is. The internet is not trusted. If it were trusted, then we wouldn't have conferences like this. The PSTN, on the other hand, is trusted. All of us have to rely on it to do just about anything, like order food or stuff late at night. So we need the PSTN, and they're breaking it, and it's going to be very, very easy to break, and I'll show you how to do that. So one of the major problems is that it's been around for such a short period of time that the best practices are very, very immature. No one really knows what good voice over IP security looks like. So they just go and they buy a bunch of boxes from a bunch of vendors, plug everything in, hack it together until it works, and then leave it there and hope that no one knows how to hack it. And that was the case up until 45 minutes from now. The really good news for us is instead of cheap phone calls, we now get free anonymous phone calls. Okay, that's one better. Okay, VoIP overview. So, all right, this agenda clearly departs from the previous agenda, but that's A-okay. So we're going to look at the infrastructure, what a voice over IP infrastructure looks like. We're going to look at the protocols that are used with the various elements of that infrastructure to communicate between each other. We're going to look particularly at the two main types of protocols, which are signaling and media protocols. I'll go into their difference. And then the integration protocols, which are used to marry the voice over IP network to the PSTN. So these are the bits of the infrastructure that are actually important. You have an actual telephone at one end, or a user agent. This is a mobile phone at some point in the future, I hope, or a soft phone, which is running on a PC, or it could be a hardware phone that supports the protocols directly. It can even be a router, which does conversions from analog telephone lines to voice protocols, and then sends everything over DSL. There's the internet technology, which is then like whatever, the internet, routers and DNS. Those are the major pieces of voice over IP technology that are used in terms of internet-specific technologies. And then the integration technologies are basically gateways. They're called gateways because they act as gateways between the PSTN, which is a walled garden, and the internet, which is a wild, unkempt garden. And of course, there's two types, the media and the signaling. So if we look at the protocols which are used to communicate between these various devices, we have the primary sort of central theme is the separation of signaling and media. So media is actually everything that's voice traffic. all of the actual content, like in the future they expect to have video traffic, or they're actually talking about text over IP, which I don't really understand how that's different from what we have now, but they intend to have voice over IP, text over IP, and video over IP, and I believe they want text over IP because they think people are stupid and will stop using MSN for free and start paying for text messages over the internet. There are a couple of competing standards in terms of the signaling protocols. The two primary ones are H.323, which is very old, and SIP, which is not very old, but it's very big and cumbersome, though not quite as big and cumbersome as H.323. SIP tends to be what's used in the new rollouts, whereas H.323 tends to be legacy software. In theory, there's supposed to be a parity between the amount of H.323 devices and SIP devices out there. In the work that I've done, I have yet to encounter an H.323 device. So I'm not sure how widespread it actually is anymore, given the rapid explosive growth of SIP-based devices over the last year or so. The other big competition is between the H.323 related Megaco, which is used for media integration between media gateways, the PSTN, and the internet, and MGCP, which is just a legacy piece of shit. But it's been around for long enough that it's really entrenched itself in deeply. There's also a bunch of proprietary stuff out there, such as Skype, which a lot of you probably use. I don't know much about it, no one really does, but they've now been bought by eBay, so there's that. As I said, SIP is basically used for all the new stuff, so if you're going to learn about voice over IP, learn about SIP. Okay, signaling protocols. As I mentioned, there's H.323. It's a very, very old standard. It was like, I have a CD-ROM that came with my Slackware 7.0 or something like that, and it includes a bunch of documentation, and one of them is how to get voice over IP working with Linux, and it only talks about H.323. So H.323 has been around for a long time. It's based on ASN1. For anyone who knows anything about security, the words ASN1 mean pain, convoluted, complex, and basically broken. It's most likely vulnerable. Right? Anyone who remembers from a couple years ago all of the ASN1 bugs that were coming out, they should realize that no one's actually looked at any of the H.323 implementations with those. So, broken. If you want to develop attack tools, don't. H.323 only has the open H.323 library, which is very, very painful to use. I spent 2 days working on it and then decided that I didn't want to know anything at all about H.323. It was just too painful. It's not good for attack tool development. You have a very, very high-level API that makes no sense. Okay. This, on the other hand, is cool. SIP. SIP is the Session Initiation Protocol. It's used to negotiate and set up sessions between calling parties or calling agents. It's defined in RFC 3261. There's a previous RFC, which I don't remember, but that's been obsoleted. This RFC is pretty big. It's one of the largest RFCs that's been published and is in use. It's about 300 pages long. Most of it is crap. You can skip a huge amount of it. It explains everything in absolute verbose detail. SIP will look very, very familiar to people, even if you've never seen it before, because it's based heavily on email and HTTP. So it's a text-based protocol. It has error codes, such as 200 OK, or 404 not found, or 403 forbidden. And it has a method-based means of access, which looks a lot like GET or POST or PUT with HTTP. So, let's see. Transportation layer. So SIP is basically a high-level protocol which runs on top of underlying protocols. The general idea is to run it on top of TLS, on top of TCP. The practical implementation is always on top of UDP, which means you can spoof SIP messages very, very easily, and you can inject them into sessions without too much trouble. In terms of the IP layer, you can drop things in. It gets a little bit more complicated in terms of the portions of the protocol within SIP that you need to guess or derive, but fortunately most of the people developing SIP software are idiots, and they don't use proper randomness. So you're not going to have too much trouble if you actually look at any devices. So while I can use TCP and TLS, I have not really seen that. I've seen there's one person out there working on a version that supports a secure implementation of SIP by default, and their software doesn't work. So everyone else uses UDP. Okay. There's some issues with SIP in particular in terms of the call setup. It uses these very, very complicated state engines, which are defined very well in the RFC, but you tend to fall asleep before you finish reading the sections. So I'm not sure how well they've actually been implemented. I've yet to find actual attacks using the state engines because I fall asleep while I'm reading about them, but I haven't had to go that deep into the protocol to break things. So maybe next year. There's a lot of open source SIP stacks out there. There's one from GNU, which I would recommend that you never use ever. There's another one from the old SIP Xperia people. Again, I wouldn't recommend using it. It's done in C++, and it's kind of big and bulky, and the actual API for SIP packet manipulation is great, and then the API for sending SIP messages is horrible. There's implementations of SIP in Python, in Java, in just about everything. The Java implementations, by the way, are very funny because they expect the protocol to be actually delivered correctly. So if you send a response that has a non-numeric initiation, so if, instead of saying 200 OK, you write out TW00 100 OK, it will cause exceptions and the entire stack will crash. Right? So while that's outside the scope of the RFC, you should never send something like that. The Java guys never really thought that someone would actually send bad SIP packets. All right. So if we look at what a SIP packet actually looks like, which we'll do in the next slide, I hope, we have a command line and a series of header fields, and then we can also have a message body. The message body is typically comprised of MIME data, and the MIME data that everyone uses is STP, which we'll look at later on, which is called the Session Description Protocol, which is used to initiate or define how the RTP, which is the media protocol, will work. The command line, which always has to be the first line in a SIP message, is made of either a method and a URI, which is like invite this URI or cancel this or whatever. Or it's made up of a response code and a response, such as 200 OK or 404 not found. The header fields are then made up of a name, colon, a value, and the value can be a comma-separated series of value lists. Sorry, a semicolon-separated field of value lists. We'll look at an actual SIP packet now. So here we have an invite packet, which is going to set up a call. It's taken straight out of the RFC. As I said, the RFC is very verbose. They have a 14-packet exchange, and they print out every single packet. So here we go, the invite. We start out with saying invite, it's our method. We've got sipbob@biloxi.com. Sorry, damn it. I've been getting the same text message about 60 times now, and I want to know if there's anyone from my Cellcom who works here. I'd like to recommend that you roll out your voice over IP package as rapidly as possible, and then let me know. Okay, so we have our invite. We have a URI that we're going to access, which is bob@biloxi.com, and then we say SIP version 2.0. So this should look basically like HTTP to everyone. Then we have a bunch of headers. So for instance, we have VIA. VIA is required to be in every single packet. So a lot of firewalls that believe that they do really, really cool SIP packet stuff tend to check to make sure that you have a VIA tag in there. And then they never do any authentication to make sure that the VIA tag doesn't contain malicious information. So when we do the live demo, I'll be showing you how we can get through a NAT and access some information from the back end of a server, because they don't actually look at how their VIA is used. The maximum number of times that this packet should be forwarded through proxies or various other entities. We can do a trace route using max forwards and setting it to 1, then 2, then 3, and so on. And we can also use a special SIP packet to do that, which is the options value. We'll look at that in a second. Caller ID, this is one of the things that you need to guess. It's supposed to be a very, very large random number at a host name. That's how it's defined. What we tend to find is that it's a very, very large date at a host name, and then it increments by time. So it's not that